Welcome to today's lesson from section 2.1 in our book titled Quadratic Functions. I'm sure you remember from your previous math classes thinking quadratic equation. A quadratic function is any equation in the form ax squared plus bx plus c. The only thing you have to remember is a has to be any number other than 0. And that makes it a quadratic function. All right, this graph, what you're going to get for a shape when you graph it is known as a parabola. As long as a is bigger than 0, aka a positive number, that parabola is going to open up. Anytime a is less than 0, that parabola would then open down. I'm sure you've seen this in some of your prior courses. What we're going to focus on primarily today is called the standard form of a quadratic equation or function. And that is in the form f of x equals a parentheses x minus h squared, close the parentheses, plus k. This has been known as Vertex form in some of other books, but our book calls it standard form, also associated with Vertex form. The nice part about this quadratic is you can immediately tell what the vertex is. And the vertex is going to be what h comma k. So if you've got a function written in our standard form, there's not a lot of work. You know exactly where the vertex is, and it makes it a lot easier to graph. Okay, so here's just a couple quick transformations that we can use to graph this first equation right here. This is a standard parabola, and this parabola with a factor of 1/3 on the outside is going to make it rise less fast. It's going to actually kind of fatten out the parabola. Now you know 0, 0 is going to be your vertex here, and what's going to happen is your a normal parabola, y equals a normal parabola, y equals x squared is going to be right here. This would be y equals x squared. But ours is going to rise actually not quite as fast. What we would have is our parabola would actually rise 1/3 as fast. So it would instead pass through, still pass through 0, 0, but it'll pass through about 1 comma 1/3, and it would also pass through 2 comma 4/3. Same thing with the negatives. So this right here, this graph in red would be a good graph for y equals 1/3 x squared. The second equation is actually in a little bit more in vertex form. They're both in vertex form, but this one you can see actually has a transformation left and right. There is no transformation left and right here. There's actually a transformation up and down, because if you think of your vertex form, h is 0 and k is 1. So that's saying here our vertex form, our vertex is actually 0, 1. So when we go to graph this line, the vertex is going to be right here where this green dot is. And because it is, there's a negative in front, this parabola is going to open down. And what I like to remember about a parabola is there are really 5 important points that a standard parabola always has. The first one is the vertex. If you go over 1 and then down 1, you've got another point on the parabola. If you go over 2 and down 4, that's going to be another parabola. So from the vertex, over 1, down 1 gets you a point, and then over 1, down, over 2, down 4 from the vertex will get you points, as long as there's been no factors in front. If you noticed in the last problem, there were some factors in front, and it switched how fast the graph rises. All right, so right here what you have is, to put a quadratic equation into vertex form, you're going to need to complete the square. And completing the square can be a little tricky, but I will show you on the next couple slides. This is a good opportunity to read through these steps. The key part to this step that most students make mistakes on is actually right here. You need to have a 1 in front of the x squared, or you cannot do this problem. And I will show you how to work around that later in the notes. This b over 2 squared becomes an important step that people need to remember. And I would pause it right here, take some notes, and then proceed to the next slide. Here's where we're going to complete the square to put this in vertex form. And if you noticed in the notes, we said that we need to have a 1 in front of our x squared, and this problem is a little trickier because there's not a 1 in front of this x squared. So to accomplish that is what we're going to have to do is we're going to have to look at just the first two terms, see, and we're going to have to factor out whatever number is here. In this case, it's a 2. So I'm going to be able to rewrite this equation. F of x is equal to 2 times the sum of x squared plus 4x, and then I leave the plus 7 outside the parentheses, and I never factor out of that plus 7. I'm going to leave it exactly as is. Okay, now what I focus on is the x squared plus bx, and I'm going to have to, that's where I'm looking for my b value, which in this case, our b value is 4. So keeping in mind b over 2 squared and x squared plus bx. So the 4 is going to be our value for b. We're going to take that, square it. So 2 squared. We're going to look, we get a number 4. That 4 needs to be added inside the parentheses. So when I copy this over, f of x equals 2 parentheses x squared plus 4x plus 4. That's going to make this trinomial inside the parentheses very easily factorable. Now, the tricky part is, if I add 4 inside the parentheses, it looks like I wrote plus 4 on my paper, but I actually wrote plus 8 on my paper because 2 times 4 is 8. To keep the balance in the equation, if I've added 8, I also must subtract 8 outside the parentheses, because what I really did, 2 times 4, I added 8, and then I need to subtract 8 to keep the balance in the equation. All right. Now, as mentioned before, the first trinomial becomes very easily factorable to x plus 2 times x plus 2, and then I can combine some like terms here and say minus 1. Now, normally, we don't write the equation like this. Every time you complete the square, you're going to get a perfect square here, and it's going to be x plus 2 squared minus 1. So graphing this is going to be not too bad, because when you go to graph, the vertex, I can see, because I'm in standard form now, that the vertex is going to be negative 2 comma negative 1. So if I'm going to graph, I can find negative 2, negative 1 right here on my graph. And I've got a parabola that raises twice as fast as usual because of this 2 right here. I know the parabola y rises twice as fast. So if I know this is my standard vertex right here, normally for a parabola I go up 1, but it's rising twice as fast, so I'm going to go up 2. So over 1, up 1, but I'm going to go double that because it's rising twice as fast. 2 over. And what I would normally do is go up 4, but I'm going to go double that. Put this point on, and I'm going to find the same thing. On a normal parabola, I would go there, but I'm going to go double that. It's up here, and then the bigger dots is going to be my parabolas. This is a good one to try on your own in your notes. What I would suggest is I would warn you, again, you're going to need to find a number to factor out. Look to factor out whatever number is in front of x squared. Factor that out. Give it a shot. It is extremely similar to the last problem that we just did. So pause the video, try this problem, and we will likely go over it in class tomorrow. Write the standard form equation of the parabola whose vertex is 1, 2, and passes through the point 3, negative 6. So what we have here is, right here we have our standard form equation, and they've actually given us quite a lot of information. They've given us h and k, because this is part of our vertex. And they've also given us a point on the line, so they've also given us x and y, or x and f of x if you prefer. And if I substitute all that information in, I will be able to solve for a. So let's take a look at how that's going to work. If I substitute in, I have f of x equals, if I just substitute in the vertex first, I have a parentheses x minus 1 plus, squared plus 2. And because I also have x comma f of x, I could substitute in a few numbers. Negative 6 equals a parentheses 3 minus 1 squared plus 2. Now we're just going to use some straightforward algebra to solve for a. So I can subtract 2 both sides. I get negative 8 equals, that's a times 2 squared. 2 squared is also known as 4. So we got negative 8 equals 4a. Divide both sides by 4. A equals negative 2. That value is going to be substituted in to our equation along with our vertex. We no longer need the point that we passed through, and we'll be able to create the equation f of x equals negative 2, parentheses, x minus 1 plus 2.